Hi, welcome to my sixth video in the playlist of abstract algebra. In this video, I am going to talk about homomorphisms and isomorphism. So, I kindly recommend you to watch this video above 360 pixel for better quality. Now, what is meant by an homomorphism? Let G with respect to some binary operation, let's say star, and G dash be another group with respect to some composition, let's say dot, be two groups. We have two groups with respect to some operation. A mapping F from G to G dash is called a homomorphism if f of A into B is equal to f of A into f of B. Note that here the operation here corresponds to the group 1 and operation here corresponds to group 2. That is the operation of G here and operation of G dash here. If a function satisfies this condition, we say that f is a homomorphism from G to G dash. Now what is meant by isomorphism? If that function f happens to be 1 to 1, then that homomorphism become isomorphism. That is a function here, it is a function. If that function is 1 to 1, then homomorphism become isomorphism. So this is what meant by homomorphisms and isomorphism. Now I will give an example to find how to find a homomorphism between two groups. So this is a question. Find all homomorphisms and isomorphisms from Z8 to Z4. You know what is meant by Z8? It is an addition modulo group containing 8 elements from 0 to 7. And Z4 is again an addition modulo group containing elements from 0, 1 to 3. So here Z4 has 4 elements and Z8 has 8 elements. Now we are going to find all homomorphisms and isomorphisms from Z8 to Z4. So how can we find this? First, we want to find the possible order of an element for Z8 and possible order of an element for Z4. So how to find the possible order of an element for Z8? First, you find the possible divisors of 8. Possible divisors of 8. And then you will find possible divisors of 4. Possible divisors of 4. So possible divisors of 8 are 1, 2, 4, 8. And possible divisors of 4 are 1, 2 and 4. Now you want to pick an order of an element which is both divides 4 and 8. So among this, these are the 3 elements which divides 4 and as well as 8. So we want to choose an element order of A which divides 4 and order of an element should also divide 8. So here we have 3 possibilities for order of A, which is 1, 2 and 4. So the first possibility, if order of A is 1, and the second possibility is order of A is equal to 2, and third possibility is order of A is equal to 4. Now order of A is equal to 1 means 1 times A, 2 means 2 times A, here 4 times A. Now here you should not read 1 into A, 2 into A. Here this dot represents the binary operation. Here the binary operation is addition modulo 4. You want to choose an operation from the codomain which is Z4 here. So Z4 has 0, 1, 2, 3. So here you have 4 elements and you want to choose an A in which first you will always remember that now we want to choose an A in which 1 times A is 0, and then you want to choose an A in which 2 times A is 0, and then you want to choose an A from Z4 for which 4 times A is 0. Now 1 times A is always a trivial homomorphism which is f of x is equal to 0x. Now we want to pick an A from 0, 1, 2, 3 in which 2 times A, that is if A is equal to 1, then it is 1 plus 1 which is 2, and you want to get 0 as an answer. So if I pick A is equal to 1, then I have 2 times A, that is 1 plus 1 which is 2 mod 4 which is 2. So it is not equal to 0. So I cannot pick A is equal to 1. Suppose if I pick A is equal to 2, then I have the 2 implies that we want to add 2 times. So 2 plus 2, which is 4 mod 4. So we have, so this is a possible choice for A, because 2 plus 2, which is 4 mod 4 is 0. Now if A is equal to 3, then we have 3 plus 3, which is 6 mod 4, which is 2. It is not equal to 0, so this is not possible. So if R of A is equal to 2, then we have only one possibility for A, for which 2 times A is 0. So therefore, now we move on to, if order of A is equal to 4, if order of A is equal to 4, this implies 4 times A is equal to 0. That is, we want to add 4 times, then we want to get 0. Now first, if A is 1, then 1 plus 1 plus 1 plus 1, which is 4 mod 4, which is 0. So this 1 satisfies this condition. If 2, then 2 plus 2 plus 2 plus 2. Now 2 plus 2 is 4. Now 4 mod 4 is 0. Now 0 plus 2 is 2. 2 mod 4 is 2. 2 plus 2 is 4. 4 mod 4 is 0. So this satisfies. Now if for 3, then 3 plus 3 plus 3 plus 3. Now 3 plus 3 is 6. 6 mod 4 is 2. 2 plus 3 is 5. 5 mod 4 is 1. And 1 plus 3 is 4. 4 mod 4 is 0. Now 0, here we already written the trivial homomorphism. So we no need to add 0 plus 0 here. 0 plus 0 plus 0 plus 0, because already done here. So we no need to add 0 4 times. We obviously get 0 as answer. Now when you look at this, what are the possible values of A for which 1A is 0? So this one homomorphism. And here if A is equal to 2, then this happens to be 0. And again if A is 1, 2, 3. So here we have 4 homomorphisms, which are f of x is equal to 0x, f of x is equal to 2x, here f of x is equal to 1x, 2x we already done here, so we don't need to write this 2, and f of x is equal to 3x. So these are the 4 homomorphisms from Z8 to Z4. So when you see the definition, that is f of A star B is equal to f of A into f of B. So these are the 4 functions which satisfies that condition which is given in the definition. Now this is very important. Now I am going to give a trick to find the number of homomorphisms from Zm to Zn. In general, I am going to give one shortcut to find the number of homomorphisms from Zm to Zn. So this is very important. So kindly take it down. Number of homomorphisms from Zm to Zn is GCD of m comma n. So this is a very important result. In exam they might ask the number of homomorphisms from Z10 to Z20. So you just simply you need to find the GCD of 10 comma 20. So when you look at this example, here we have 8 comma 4. So therefore GCD of 8 comma 4, which is 4. So that's why we get 4 homomorphisms. And what are the 4 homomorphisms? You need to follow these steps to find what are those 4 homomorphisms. The 4 homomorphisms are 0x, 2x, 1x and 3x. So this is a way to find the number of homomorphisms. Now total number of homomorphisms can be found by GCD of m comma n. It tells the number of homomorphisms. And what are the homomorphisms? You need to follow these steps to find what are those homomorphisms. Now this is very important. Here we have 4 homomorphisms, and now I am going to find how many of these 4 functions are 1 to 1. If this function happens to be 1 to 1, then this homomorphism will become an isomorphism. So what is the codomain here? The order of codomain is 4. Order of codomain is 4, and you just see the coefficient of x in all 4 functions, which is 0, 2, 1 and 3. Now this is a condition for 1 to 1. Now I will give a condition for 1 to 1. Condition for 1 to 1. So this is also very important. From these 4 functions, I am going to find which of these 4 functions are 1 to 1. So condition for 1 to 1 is when the GCD of order of codomain and the GCD of order of codomain and coefficient of x is 1, then that function, then f is 1 to 1. So this is a very important condition. When the GCD of order of codomain and the coefficient of x becomes 1, then that function will become 1 to 1. So here we have codomain as Z4. So order of Z4 is 4. Here we have 4 homomorphisms which are 0x, 1x, and f of x is equal to 2x, and f of x is equal to 3x. So these are the 4 homomorphisms which we found earlier. Now I am going to check which of these are isomorphisms. Now first, GCD of order of codomain is 4 and coefficient of x here is 0. So which is 0? It is not equal to 1. So therefore f is not 1 to 1. Now second function, GCD of 4 comma coefficient of x here is 1. So which is 1. So therefore f is 1 1. Now third, GCD of 4 comma the quotient of x is 2 here, which is 2. It is not equal to 1. So therefore f is not 1 1. And fourth, GCD of 4 comma 3 is 1. So therefore f is 1 1. So out of 4 homomorphisms, 2 functions are 1 to 1. So number of isomorphism from Z8 to Z4 is 2. So number of homomorphisms can be found by simply finding the GCD of m comma n, and what are the homomorphisms can be found in this way. So these are the 4 homomorphisms, and out of those 4 homomorphisms which are isomorphism, you have to verify that if the GCD of order of codomain comma quotient of x happens to be 1, then this function f becomes 1 to 1. So therefore it becomes isomorphism. So in the next video I will give another example to find the all homomorphisms and isomorphisms from another group, and I will solve some previous year's net questions based on homomorphisms and isomorphisms. Hope you enjoyed this video. We'll see you in the next video. Goodbye.